let's talk about the easy system. Now, for your alkenes that are tri or tetra-substituted, right, you have to use E and Z. You can't use cis or trans, right? Now, in order for you to assign easy, you have to remember the same rules that you use to assign RNS to your enantiomers, diastereomers, etc. Right? So once you determine that your alkene is tri or tetra substituted, right? You assign priority comparing these two groups that are bonded here, right? Assign priority comparing these two groups. Then you go over here, assign priority comparing these two groups. If after you've assigned priority, the groups of higher priority are on the same side of the carbon-carbon double bond, then what we have is a Z molecule. Z is similar to cis, right? And when I say same side, whether higher is above or below, it's Z. Just needs to be on the same side of the carbon-carbon double bond. The example that what's drawn here shows the groups of higher priority above. Okay? And if after you assign priority, and we're going to do some examples, your group of higher priority is on opposite sides of your carbon-carbon double bond, then it's going to be E. So E is similar to trans, right? So carbon-carbon double bond, group of higher priority, one is above, one is below, then it's E. I'm going to use an example couple examples, three examples, to explain one, if it's tri or tetra, because a lot of questions will not tell you if you should use E or Z. You have to determine that. Just remember that for you to use E or Z, it must be tri or a tetra substituted alkene. That's the first thing. And you need to remember priority rules. So let's go ahead and do our first example and capture all of these. So I need you to remember the groups of higher priority. If they're on the same side, it's Z. If they're on opposite side, then it's going to be E. And I'm duplicating this for a reason. So first thing, let us determine, do I have a tri or a tetra-substituted alkene? In order for you to determine that, right, go ahead and first thing, always do this. Find your carbon-carbon double bond, and if you have any hydrogens on those carbons, put them in. So on this carbon right here, I have one hydrogen. If you don't know why, you need to go back to learning how to draw a line angle formula. I have one hydrogen here, right? And I know it's pointing up because my bonds meet pointing up. So the hydrogen here points up. Now, let me determine if it's tri or tetra substituted alkene. All you have to do for that is circle the groups that are singly bonded to the carbons of the carbon-carbon double bond. This is my carbons of the carbon-carbon double bond. I've highlighted them with a red asterisk, right? Let me now circle the carbons that are singly bonded to these red asterisk carbon. These are the groups that are singly bonded, right? Now, after that, count how many groups you have that are not hydrogen. 1, 2, 3. So this is a tri-substituted alkene. Easy, right? Yeah. Tri-substituted alkene. Cool. Now, let us go ahead and assign priority. We need to assign priority to the groups that are bonded to the carbon-carbon double bond. And this is what I mean by that. I'm going to put my hydrogen over here for this one. And that's why I had two structures here. So that's my hydrogen, right? This is my hydrogen. All right, cool. Remember what I said, right? I'm gonna just highlight these, right? To assign priority, please don't forget, you're assigning priority, you're comparing this group with this group to assign priority. That's the first thing you're doing, right? So you have two carbon-carbon double bond. You're assigning priority to the carbons that are singly bonded, but you're doing it on each side, right? So I'm going to compare this group to this group and figure out which one has the higher priority, okay? And let's do that. Once I'm finished with this side, then I can move over here to assign priority, all right? So do each side of the carbon-carbon double bond. So you're comparing this to figure out which one has, which group, either the one at the top or the one at the bottom has the higher priority. This is how you do that. Here's my carbon of the carbon-carbon double bond. I'm just going to call this 1, 2. Clearly, that's not how I would do it if I'm naming. I'm calling it 1, 2 so we can talk. So directly bonded to carbon 2, I have a carbon with 3 hydrogens on here. And I know this from my line angle formula. You should know where I get the 3 hydrogens, all right? Directly bonded here, I have a carbon that has a hydrogen and a carbon bonded, carbon bonded. I didn't put the hydrogens over here for a reason, because I don't think I need to go that far to find a point of difference. So let's assign priority here, all right? Directly bonded to carbon 2, I have a carbon. And this is what I mean by directly bonded here. It's carbon 2 directly bonded to it is a carbon in this direction. Directly bonded in this direction is also a carbon. Remember, I'm trying to determine between these two groups, the one at the top and the one at the bottom, which one has the higher priority. Since directly bonded, I have carbon. I can't use that to determine which has the higher priority. Carbon and carbon has the same atomic number, right? Your priority is assigned based on a difference in atomic number. Higher the atomic number, the higher is the priority, okay? Don't forget that. You would have learned that in RNS. So let's move on. Since I can assign, since I can assign priority based on this carbon or this one, I have to move to what's bonded to the carbon that I crossed out. Move to what's bonded to the carbon that I crossed out. What's directly bonded? Directly bonded, on this one I have hydrogen, hydrogen. All three of these things are directly bonded. Same thing here. This is directly bonded. This is directly bonded. This is directly bonded. All right. I am going to common to the carbon that is crossed out on both sides, I have one hydrogen. And it doesn't matter if the hydrogen is in the same position or if it's to the left or to the right. You can cross it out because it's directly bonded, right? So common is a hydrogen and a hydrogen, right? Then you do have a point of difference, or you have an atom that is different. I have a carbon compared to a hydrogen. I have another carbon compared to a hydrogen. Carbon has a higher atomic number than hydrogen, so this is H. That's so you are higher. You can just put H. This is gonna be low. Move over to the next carbon of the carbon-carbon double bond, carbon number 1. Directly bonded to carbon 1, I have a hydrogen. Directly bonded to carbon 1 in this direction, I have a carbon with 3 hydrogens. I don't need to go all the way to the 3 hydrogens. So directly bonded here, this direction I have a carbon. Directly bonded here, I have a hydrogen. Carbon has a higher atomic number, so this is H, and this is going to be L. Now, your H's are on the same side. Here's the carbon-carbon double bond. Both H's are below the carbon-carbon double bond. So the configuration here for this molecule is going to be Z. And you write the Z in open parentheses. Now, this has a lot going on. It's the same molecule. I'm just going to come back this way so we can name it. All right. So you name following your rules for your alkene, right? So we're going to put in the number, we're going to number our longest chain of carbons. All right, so here we go. Let's number our longest chain of carbons. Carbon 1, 2, 3, 4, 5. I could not number in the other direction, right? Because the double bond would have been 1, 2. It would have been between 3, 4. All right. Now, we have already established on this side that the configuration here is Z. So to name this, right, this and this is the same thing. All I did was remove the circle so I could name. You write Z in open parentheses, right? I have two substituents. Remember you list your substituents. They're the same. I have a methyl group here, and I have a methyl group also on carbon number 4. So this is going to be 3, 4 dimethyl. I have 5 carbons in my longest chain, 1, 2, 3, 4, 5. And my double bond is between 2, 3. Pick the lower number, so it's 2 pentene. Okay, so that's how you would name that, right? Based on that, I think you have enough to name this by yourself in the comments. Name that one on your own in the comments. I'm gonna drop it over here. So you go name that one. This one is a little bit more complicated, and I want to show you this. Let's try to name this. All right, cool. First things first, you should have named this already. I have so much confidence in you. You should have named that one already. Here is what we're going to do. All right, cool. Now, first thing, we need to determine if this is a tri or a tetra-substituted alkene. You should see that it's tetra, right? So carbons of the carbon-carbon double bond. Let me duplicate this. I'm going to need to. Let me make another one so that when I name, we have it. All right, cool. So let's focus. I'm gonna move this out the way so your attention is just right here. All right. So first we need to determine, do I have a tri or a tetra-substituted alkene? Remember how to do that. Find the carbons of your carbon-carbon double bond and then circle the groups that are single bonded to it. That is singly bonded to this carbon of the double bond has this singly bonded to it, and that singly bonded to it. This one has this one has that. So I have circled my 4 groups. The next thing you need to do, right, is look to see how many of these groups are hydrogen, right? Or count how many groups are not hydrogen. 1, 2, 3, 4. So this is a tetra-substituted alkene. Cool. Now that we know it's tetra, we know we can apply E or Z to the name. So let's go ahead now. And your next thing to do is assign priority. So let's assign priority. All right, let's assign priority. So find your carbons of the carbon-carbon double bond. They're here, right? That's the carbons of my carbon-carbon double bond, which means I am now going to assign priority comparing this to this to see which one is H and which one is L. Now, don't make this mistake. Don't be like, oh my goodness, I have way more carbons over here. So yay, this should, or because you see the iodine, you're like, yeah man, this right here is H, right? Don't do that. Always take it step by step, atom by atom, just to make sure you're doing it right. So let's go ahead, right? And let us try to assign priority. Remember, you're only assigning priority based on these two first, then you move over here. Don't forget that. So directly bonded to this carbon, I have another carbon with 2 hydrogens. Here I have a carbon with 1 hydrogen, 2 carbons. And I'm putting in stuff as I need. So directly bonded in this direction, I have a carbon. Directly bonded here, I have another carbon. cross this out. The atomic number of carbon, they're the same thing. None of them is different, so you cannot assign priority based on that. One has to be different with a higher atomic number, okay? Carbon has a hydrogen. Carbon has a hydrogen. It's directly bonded to it. I'm going to take it out. And I did that on purpose to show you it doesn't have to be in the same position for you to cross it out. It just needs to be directly bonded to it. I know I am left with, I have a hydrogen and I have a carbon. Let's look what we're comparing here. Directly bonded to this carbon that I crossed out, we're not done with that, right? Directly bonded, I have a hydrogen, hydrogen common to both of them, cross it out. You're crossing out what's common, right? Here, I have a hydrogen and I have carbons, and I have a carbon directly bonded. So here I have crossed out, I have a carbon directly bonded, and I have a hydrogen. Crossed out carbon, I have a carbon, carbon. So directly bonded to this, right? I have found something that's different. I have a carbon, right? Directly bonded to this. I also have a carbon. So yes, I can cross this out. But what I'm left with to compare, I am left with a hydrogen and a carbon. Carbon has a higher atomic number than hydrogen. So this is high and this is low. Let's move over. Directly bonded here, I have a carbon with two hydrogens to it. Here I have also a carbon with three hydrogens, right? So directly bonded in this direction, I have a CH2. Directly bonded in this direction, I have a CH2. Cannot assign priority based on that. They're the same, right? What I'm left with that is directly bonded to what I just crossed out is a hydrogen directly bonded to this is a carbon, right? So I already crossed out your CH2 because in this direction, directly bonded here, I have CH2, directly bonded here, I have CH2. I'm trying to find which one of these has the higher priority, right? And with priority, you go until you find a point of difference or it's a different atom. Cannot assign priority because CH2 is bonded here, CH2 is also directly bonded here. Cross them out and then look at the next atom that's directly bonded to what you crossed out. It's a hydrogen. Up here, it's a carbon. So you're now comparing carbon to hydrogen. Carbon has a higher atomic number than hydrogen, so this is high, this is low. My H's are on opposite sides of the carbon-carbon double bond. There's my carbon-carbon double bond. There's one hydrogen here, there's one here. Opposite sides, which mean that this molecule is E. FYI, Z is similar to cis, E is similar to trans. You can't use trans instead of E though. No, remember which alkenes we apply cis and trans to, and E and Z. All right, so this molecule is E. Now let's name the molecule. And don't forget this one over here in the corner is for you to do. This is a BR. Let's name it. So to name this molecule, right, you have to make sure you number in the correct direction, right? Your longest chain in this molecule, 1, 2, 3, 4, 5, 6, 7, 8. Don't forget this is a carbon. 1, 2, 3, 4, 5, 6, 7. So this is your longest chain. The key is what direction do you number in? Okay. Now I'm gonna play with something here just to show you something. If I number 1, 2, 3, 4, 5, 6, 7, 8, right? Let's talk about where your double bond is and where your substituents are. Here, with my blue numbers right now, your double bond is between 4, 5. Iodine is on number 8, right? On 4 and 5, 4 I have a methyl group, and on number 5 I have an isopropyl. I have an isopropyl group. So that's one way. What if we number in the opposite direction? Let's see what happens in the opposite direction. If we do 1, 2, 3, 4, 5, 6, 7, 8. Here, the double bond is still 4, 5, but let's see what's going on with our substituents. On carbon number 1, right, we have the iodine. On carbon, we on still 4, 5. So on 4, we have our isopropyl. And on 5, we have our methyl. So if you look at the blue numbers, the double bond is still here in both cases. So now the question is, all right, cool. It doesn't matter which direction I number in, my double bond is still 4, 5, right? So I don't have to worry about my double bond falling in the right position if I number blue or red. But the key is now look at your substituents. If I number with blue, right, on I'm getting a substituent on 8, I'm getting one on 4, I'm getting one on 5. If I do red though, I get a substituent on 1, 4, 5. This is a lower set of combination of substituents. So we would go red. You have to remember that when you do your alkene, the double bond rule, yes, but you also have to pay attention to like your lower combination of substituents, especially in a situation like this, because the double bond, no matter what you do, falls the same place. So let's name this. This would be, we already established that it is E, and I'm going to have to erase your blue. We already established that it is E from up here. Remember, we did all of that work. So it's going to be E, right? Now we're going to list our substituents in alphabetical order. So it's 1, iodine is iodo, O comes before S, 4 isopropyl, 5 methyl. My double bond is between carbon 4 and 5. 4, 8 carbons in my longest chain. Octene. That's a long name. That's how you would name that molecule.